Okay, for those of you who are watching the Death Packet video, this is the Death Packet. It said it was due February 21st. That was pre-weather. So obviously it's due the 28th, which is Sunday, which is tomorrow. So please make sure you have that posted by 11:59. I know y'all are all concerned because you have two tests this week. The first test is primarily going to be on proportions and type 1 and type 2 errors. The second one can cover anything during the third quarter, but we'll have a substantial focus on 1 and 2 sample t-test, paired t-test, and also we'll have a focus on type 1 and type 2 errors. On either one of the tests, either the one you take Monday, Tuesday, the first test, or the third quarter exam, either one could talk about sample size. And I understand that there's a lot of sample size questions. And we don't have a whole lot of those in this Death Packet review, but in the notes, page 187 was an FRQ example, and page 188 to 190, there was multiple choice questions. And you're like, well, that's not very helpful to me if I didn't know how to do it. And you're right. So I will be attaching videos. So look for the video links because I have those problems work out. I have page 188 videos, or page 187, the FRQ that was done in class. And I also have the multiple choice questions, page 188 to 190 worked out. All right. All right, so let's start with problem number 1. So problem number 1, first off, I was really thrilled that this was going to be asked because I was like, if it wasn't asked, I was debating whether to bring it up or not on my own or myself. So it says, which of the following is a true statement? And so the sampling distribution of p hat has a mean equal to the population proportion. Well, that's the actual answer, but just me telling you the answer probably doesn't do you a whole lot of good. So first off, there's a couple things that you need to know. When we take a sample, if we're talking about a mean, we assume that our X bar equals the population mean. All right, we believe that to be the case. We believe that our sample mean equals the population mean when we take a sample. Likewise, when we take a sample for proportions, we believe that p hat, the sample proportion, equals the population proportion, because we believe these two are known as key phrase unbiased estimators. We have not really used that phrase. I'm using it now. They are known as unbiased estimators. So X bar is an unbiased estimator for mu. P hat is an unbiased estimator for P. And someone is going, are there any other unbiased estimators? And the great answer for AP statistics is no, there are not. And you're like, well, what does it mean that it's unbiased? Unbiased means it actually equals what we think it does. So we actually believe this equals this. So we believe this is not biased. It's not over or under, it is equal to. We believe that this is not over or under, we believe it is equal to P. All right, now, the reason I was excited that this is being asked, and this is actually a very complex concept. So this concept is extraordinarily complex. But when we do our null hypothesis for proportion is when we do a two sample, we go, all right, P1 equals P2. Or actually, even if we go with a one sample, we say P1 equals some value. Well, guess what? When we do the one sample proportion test, it's P hat minus P naught over P naught, the square root of P naught and 1 minus P naught all over N. And that should be a P naught. And I didn't use P hat. Why? Why didn't I use P hat? Because I believe that these two are equal but this is actually what it is. All right. So consequently, this is an unbiased estimator. This is our unbiased claim. So really important there. I'm going to pause this and ask if there's any questions else on part one. Well, you know what? Let's look at this. The sampling distribution of p hat has a standard deviation equal to this, NPQ, and the answer is no. That's not what the standard deviation is. That's the standard deviation of the binomial. All right, that is the standard deviation of the binomial, but the standard deviation for p hat is this, p naught q naught over n. Okay, obviously if we're working with a confidence interval, so this would be the hypothesis test. So this is the hypothesis. If it is a confidence interval, the CI is going to be p hat q hat over n. But whenever they talk about the sampling distribution, if they're talking about the sampling distribution, that's the key phrase because that indicates a normality. Anytime you use sampling distribution of X bar, sampling distribution of P hat, that indicates normality. So we're going to say, oh, we're talking about normality. So P naught Q naught over N, or if you prefer, P times 1 minus P over N. P times 1 minus P over N. All right. The next one, the sampling. So we did this one. We said that that's false. C, the sampling distribution of p hat has a standard deviation which becomes larger as the sample size becomes larger. Well, as n gets bigger, n is in the denominator, it's dividing. So as n gets larger, our standard deviation, as n goes up, our standard deviation decreases. So they move in opposite directions. The sampling distribution of p hat is considered close to normal provided n is greater than 30. That is not true of p hat. That is true of S. For p hat, we have to satisfy that n p hat is greater than 10, greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. If we satisfy those conditions, it's close to normal. The n is greater than 30 is for sample means, not for proportions. All right. The sampling distribution of p hat is always close to normal. That is false. It's only true if we have samples that are large enough, and n p hat has to be greater than 10, and n q hat must be greater than or equal to 10. All right. So as I said, the question came up in the chat about the sampling distribution of p hat. They go, but isn't aren't we talking about a binomial? Isn't the underlying distribution binomial? And the underlying distribution is binomial. They're absolutely true. That's absolutely true. And I go, well, isn't that the standard deviation of the binomial? And that's absolutely true. So why is it that I'm saying that this is normal? All right, so why is this normal? Well, let's go back to when we were talking about the t distribution or the normal distribution as a whole. If I asked you the distribution of x, and you're like, well, I don't know what the distribution of x is. It's whatever it is. And that's correct. It is whatever it is. But the sampling distribution of the x bars, is normal for n greater than 30, greater than or equal to 30. So the distribution of the proportion is binomial. It is. But the sampling distribution of p hat, that's the same as saying like the sampling distribution of x bar. The sampling distribution of p hat is normal for n for a sample size that's large enough, which is np and nq greater than or equal to 30. All right, hopefully that helped.